Good afternoon, value partners, customers, staff and students of Singapore Poly. My name is Ken from Bosch. Today we are privileged to be in the first and oldest polytechnic in Singapore, established in 1954. We are in the 5G and AIoT Center today, where Singapore Polytechnic and Bosch collaborates to demonstrate use cases. For example, enforcing parking restrictions, counting people in the canteen for social distancing. Our cameras are deployed around the school, overlooking the car park, canteen, and airport hangar. We have cameras that have been built with video analytics, data-driven security using the Intelligent Insight software, where people counting and object detection is there. My colleague Adrian will display and show you the HDRX cameras that provide superior imaging technology, which optimize video capture in scenes with fast-moving objects. Later, you'll see students running across the school compound, where motion blur is greatly reduced and you're able to see crucial details. You'll also meet Chi Sing, who drives the core IoT curriculum in Singapore Poly that leverages on our solutions, where students are able to first-hand work with video analytics solutions, allowing them to explore emerging AIoT technologies, preparing them for the future with industry-relevant skills. Moving forward, our future collaboration with Singapore Polytechnic will be driven by 5G. Now sit back, relax, and enjoy the short introduction video. Thank you.
Hello, good afternoon everyone. Thank you for your time and attendance to actually come together with us here for this technology talk that's hosted by Bosch Building Technologies in collaboration with Singapore Polytechnic. We're indeed very privileged to be here today to be able to share with you some of the technology topics that are very, very relevant for the modern world of artificial intelligence, as well as IoT. So in particular, we would like to be sharing with you two topics today. One of it will be related to how we can actually utilize data that's being generated from by utilizing a software called Intelligent Insights. Second topic for today would basically be around the importance of camera technologies when it comes to trying to use video images for the purpose of analytics as well as AIoT solutions. In particular, we will be covering very specific technologies related to these type of cameras, and I would share more with you later on. So without further ado, we would jump into the first topic. And in order for us to do that, I would like to be able to first show you on screen one of the cameras that we have installed around the compound of Singapore Polytechnic, right? So if we could bring the first camera view on screen. Right, so what you should be seeing on the screen right now is basically a live video feed from one of the surveillance cameras that is installed on the compound in Singapore Polytechnic today. So what you can see here, it is basically a camera that's of course overlooking a car park. So you would agree with me that the scene is something that would be something quite typical that you would utilize for the purpose of surveillance, because after all, this is an area where you experience high activity, be it in terms of people parking their cars in a compound or moving around the compound, getting to their respective places in the building. So the first thing I would like to bring your attention to is the fact that a scene like this, more than just surveillance, it actually also contains a lot of information, right? Because at the end of the day, when you look at a scene like this, not only can this scene show you how are objects moving and interacting with this environment, it will also show you things like, well, how many cars are parked or how many motorcycles are being parked in their respective spaces. So in reality, if we start thinking about a surveillance camera as more than just a security device, we can also see it, in this case, it is simultaneously a very rich sensor that's able to provide and extract a lot of information if you have the right technologies to do so. So here at Bosch, we are quite well known for implementing various types of video analytic capabilities right into our cameras. So I would further on to show you what actually runs behind the scenes on this exact same scene by showing you some of the analytic rules that has been configured onto this camera. So alluding to what I said earlier, where this particular scene, aside from serving surveillance purposes, by implementing the right video analytic capabilities, we are able to extract even more information from within the scene itself, right? Now, of course, if I were to look at the scene, it would look extremely complicated, and it is very, very hard for us to make sense of this information. So essentially, what we need in this case is to have another piece of the puzzle being put in place in order for us to take data from the camera, able to visualize it in context such that it becomes useful to whoever that it is operating. So for that, we would be introducing to you what I've mentioned earlier, a piece of software from Bosch called Intelligent Insights. So can we bring up now the sample dashboard that's being created for this particular scene? So as you can see here, Intelligent Insights is effectively a visualization software, right? So what it does is it takes the data that's being generated from the cameras, from all the very nice video analytic capabilities. It is then condensed and it is interpreted and it is then displayed and visualized in ways that becomes meaningful to the operator. So just by one glance here, we are able then to tell which of the parking lots that I am monitoring is currently occupied, which are free. I can also use it in a way to kind of enumerate and aggregate all the data such that to provide actionable information for the operator at hand. Now, we believe that this is a glimpse to what security operations is going to look like going forward into the future. Right? No longer will security personnel be sitting in front of a monitor looking at hundreds, if not thousands of cameras and hardly being able to react to the information. We believe that this type of information, if we are able to visualize it, it would then provide a lot of useful information for the operator to take necessary action. So you can imagine now, just by having a dashboard like this, you can have complete understanding of the environment around you, right? So imagine if this was a building, you would be able to utilize data that's coming from the various different cameras to understand, what is the occupancy levels at different floors? Are different spaces within my compound crowded at any one point in time? If I've got parking lots, for example, what is the usage pattern? Is it constantly full at a certain point in the day or not? So all of this will provide information for the security operator to take proactive action to manage the situation rather than sitting back and looking at a screen full of cameras and being reactive. Right? So this is one part of the solution. Now, the other points that you might want to take a look at is the fact that aside from visualizing the information onto dashboards, you would notice that there's a tiny little map on the side. This little map is a different way of how we can utilize information that's coming from the camera. So if we kind of switch the scene to show you an overlay of the actual video camera itself versus whatever that is being shown on the dashboard. So essentially what you see here is the fact that the camera that's being shown on the left side of your screen, it actually mirrors the actual overlay that is on the right hand side of your screen. Now, I don't know if you've kind of noticed that at certain points in time, you would see that on the map itself, there are particular red dots that are appearing on the map. And this red dot is actually appearing in correspondence to the actual people that's moving on the camera scene itself. Take a moment to kind of take a look at how that works. Now, why would this be useful? At the end of the day, it again goes back to the original problem statement that I was mentioning earlier. Today, security operators are highly challenged by the fact that they have a lot of cameras that they have to view at one particular time, and it is very, very hard to pay attention to the right scene at the right time. Now, if we are able to take all of this data that's being generated from the cameras, visualize it centrally into an intuitive interface like the map that's being shown on the screen, this would make tasks a lot easier for the security operator. Now, you can imagine this would bring an enormous benefit to applications such as perimeter surveillance. Instead of monitoring all the cameras that you have installed around your perimeter, instead you can basically look at a map like this without looking at the individual cameras and still be as effective, if not more effective, by being situationally aware whenever an object of interest appears and is being picked up by the camera, right? So in turn, if we kind of put an impression on you today, is the fact that with Intelligent Insights as well as Bosch cameras with its internal analytics, these two pieces come together to form a solution for the next generation video surveillance and operation center. So now that we have an idea that the camera can in fact do a lot of things with video analytics, we shall move on now to the second topic. Now, in order for us to kind of talk about the second topic related to camera technology and the importance of imaging when it comes to AIoT applications, I would now like to take a check on my colleague that is in a remote studio at this point in time. So if we could kind of bring him up so that we could take a look at him. Right. So, in case you are wondering what's basically going on screen, we have a student from Singapore Polytechnic who's happily volunteered himself to be our model for today. He is currently situated in a remote location somewhere in this compound in order for us to demonstrate the importance of camera technology. So before we go on with the actual demonstration, just to verify that he is able to communicate with us, I would like to get him to kind of wave at the camera. And just to show that communications are well and the thing can move and the demonstration can go on smoothly. Okay, so things are going good now. What we can do at this point in time is to show you what this particular model looks like when he is viewed by a security camera, right? So for this, you would basically see on screen now, we have a surveillance camera from Bosch that is being installed within this particular facility, and he is currently looking directly. It is currently looking directly at the subject that is standing at the corridor. Now, the first thing that you would kind of notice is the fact that the picture actually looks quite perfectly balanced, able to expose, necessary details for the subject at hand, as well as the details of the foreground as well. Now, this is basically made possible because in most surveillance cameras, where it is required for the surveillance camera to handle detailed imaging reproduction, even in challenging scenes where there is super bright background and there is also a pretty shaded and dark foreground, to be still able to perfectly balance and put the entire image on scene without losing too much details. All right, so this is traditionally what we know as wide dynamic range. Now, unfortunately, wide dynamic range, it has certain side effects, I would say. Yeah, in the sense that how wide dynamic range works is the fact that the camera internally exposes the image, the brightest part of the image, takes a snapshot. It exposes the darkest part of the image, takes a snapshot, and it attempts to blend together these images in order to produce this balanced view that you see. Now, earlier on, I was talking about some drawbacks to this technique. So in this demonstration, we would like to be able to show you what this limitation could look like. So in order for us to do this, I would get our student model here to basically get ready and take off and run at high speeds away from the scene, right? So in order to do that, we would now start to do so on the countdown. All right. So now he has very quickly run off from the scene, and you still might be wondering what exactly it is I should be paying attention to, right? So in order for you to do this, we have pre-recorded this video of this particular action. Just as he was doing the demonstration, we would show you now what that looks like on the recorded video. So can we bring up the recorded video for this? Right. So perhaps he is running so fast that you still what exactly it is the limitation with wide dynamic range. So what we've decided to do is take a scene from the previous video. We kind of pause it to kind of show you then what are the artificial effects that are being cropped up. All right, so give it a moment. Right, so what you see on screen is basically a freeze. Right, we kind of paused the video and we frozen the subject and we kind of zoomed in. Notice how there are a lot of artifacts that starts to show up on this fast-moving object when the camera is trying to balance the picture using wide dynamic range, right? The particular artifacts that I'm alluding to includes the white outline that's being traced on the subject, and more alarmingly, if you start to zoom into the face, you start to see some pretty obvious pixelation, right? So this is one of the limitations when it comes to cameras that has wide dynamic range and is attempting to use this capability in order to produce good pictures in spite of the challenging light environments. So fortunate to say, here at Bosch today, we currently have a new range of cameras that addresses this pain point in particular, right? So in order for us to show you the difference, we are going to repeat the demonstration again. This time, showing you and comparing what you see now versus the newer range of cameras. So in order for us to do that, the first thing again, just to check that we are getting communication with our student's model there at the remote site. I would get him again to wave his hand to show us that he's ready and good to go. Okie dokie. So he is ready and good. What we will do now is again show you now what exactly does it look like on a surveillance angle, right? So within the same space, we have put two cameras side by side, one from the previous camera that you saw, and now this is the image from the newer range of cameras. I hope for those guys who are paying attention and are really particular, you would clearly see that there is already quite a distinct improvement in terms of image quality overall based on this new range of cameras, just by having the better wide dynamic range capability, right? So we will repeat the same thing by having our students model there run off and take off at high speeds whenever he is ready. So let's count it down for him. And he should be going soon. Right. So you might again ask, well, what is the difference here this time? So in order for us to show you that, again, my colleagues in the background studio has kindly recorded this video while the demonstration is going on. So we would now show you a replay of what has been captured. So can we bring up the replay video? Right. So again, to the naked eye, this may not seem very, very obvious, but let us do the same experiment earlier by pausing the video at the points that is comparable. So we would now bring up an image of what that freeze frame looks like. Right, so here now you see that this is the actual freeze frame from the video that we shown earlier. Clearly the artifacting is a lot less. Yeah? The clear overexposed outlines on this fast moving object is no longer present. And if we kind of zoom into the facial features, or at least the head part of the image, we should also be able to see a lot less artifacting. Right? So this is essentially the technology that we have built into the camera called HDRX, or an extreme version of the wide dynamic range capability that we have inside the camera. Right? So again, this is something that is may not be super important at first blush, but if we start thinking about utilizing the cameras as a sensor for AIoT applications, essentially the effects and the artifacts from these images would become part of the consideration for the algorithms that's processing this camera in terms of video analytics. So in other words, if you produce good quality images, it actually does enhance the performance of your analytics overall. Now, in order to illustrate this, we have basically utilized the two video streams, run some analytics on the video streams at the exact same time to kind of show and compare the difference between the performance of analytics between what was a traditional wide dynamic range camera versus this camera that has the HDRX capability. So can we show the comparison video?
I told you camera to show that this is the light. I told you camera to show.
Was able to trigger a response from the video analytics that's running, whereas the other one wasn't able to. And this is largely down due to the fact that the analytics had to cope with the artifacting from the traditional wide dynamic range camera, and in turn reduce its accuracy to be able to pick up the triggering conditions, in this case, the face of the subject. And from a HDRX camera, because there is less artifacts, it in turn provides a much better result from an analytic perspective. So hopefully that kind of gives you an impression of the two topics that we wanted to share with you today. And hopefully the message is also clear that today a video surveillance camera is more than just a pure security device. In fact, it is also a sensor that is able to produce a lot of rich information. And there are 1,001 ways how you could do it. And this is even especially true for now that we have 5G technology becoming increasingly more available. So you will find opportunities to place cameras in locations where you typically deemed not possible because of 5G technology. And more importantly, the environments that these cameras would be exposed to most of the time would have challenging light conditions. And therefore, if you want to make the most out of this, it would actually be very advisable to make use of good cameras that's able to produce good quality images that enhances the performance of your analytics in general. So of course, this new camera of ours not only has the HDRX capability, but it also has exceptional night performance. So at low light conditions, it is still able to produce colored images even when the light levels are super low. Unfortunately, because the demonstration here is in the daytime, we would not be able to show you this live, but we have prepared a video for you to also show you how this exact same camera performs in situations where there is low light. So for that, I would ask for now the comparison video to be played, and I shall be seeing you guys later during the question and answer session. So please feel free to pose your questions later on. Thank you, and see you guys in a moment.
Hi, good afternoon, everyone. Thank you, Adrian, for his introduction to the two new latest technology. If you are interested, you know who to look for. But in Singapore Poly, we are very keen to work with industrial partners like Bosch to learn from them the latest technology, the key things that is available for the industries, especially in the area of AIoT topics that we are here today. So we are very glad to have them as one of our important industrial partners to work on, to skill up our students and be prepared for the industries. So let me introduce you this new center that we are going to launch. In fact, it's already launched in the morning. We call it the 5G and AIoT Center. So the first slides that you see here is going to be the 5G Garage. It's actually a collaboration we have here with Singtel. It is the first live 5G test facilities, training center, ideation lab. We use it to develop application, integrate 5G into AIoT ecosystem. For low latency, centralized monitoring, intelligent control of various industries, solution and subsystem. So the center focused to grow Singapore 5G ecosystem and drive the adoption of both 5G and AIoT technology by enterprises in their digital transformation journey. Next, this is to share with everyone that in the year 2020, which is last year, we are appointed by IMDA as the Singapore 5G and Telecom Program Manager to upskills with 5G relevant capability for manpower development. So right here in this center, the center works on proof of concept projects that involve complete end-to-end ecosystems that integrates embedded hardwares like sensors, devices, gateways, connections to cloud platforms, application development, to create that complete system. So later on, we're going to show you we're going to look into the fields, the areas of advanced manufacturing, smart facilities, urban solution, and sustainability. So right here in this slide is a list of POC projects that we do, mainly focusing in using AIoT video-based, using industrial cameras of 3 fields after earlier what we have mentioned. So all these data are aggregated to our AIoT Nerve Center for central control. So may I just ask everybody sit back, relax, and watch a short video on all the projects that we have done so far in the center. Right, thank you for watching the video. So I hope you have enjoyed all the list of projects that we have been doing. So on top of all these interesting projects that the center is working on, we also have good collaborations with Bosch in partnership in this Smart Connected Solution Lab, where we can actually play. Let us show you a video of how the lab looks like as I describe what's inside. All right, so this particular lab, we have actually having about 8 cameras installed to teach students of various video-based basics, fundamentals of what is important to capture a good picture. At the same time, we let students master and learn how to create AI rules that is very handy and that can be detected quickly over easy GUI control and dashboards. And lastly, we ask students and we teach students how to collect metadata from this camera and be able to create applications and according to the problem statements that they actually brainstorm during ideation stage. So maybe let me now invite one of my students over to stand together with me and share some of his learning experience with everyone. Anu, please. Hi, Anu. How are you feeling today?
I'm feeling good.
You're feeling good? You want to, is it okay? I think it's okay to take off the mask, right? Okay. Right. So maybe you would like to introduce yourself to all our people online, and why do you choose School of Electrical Electronic Engineering in Singapore Poly?
Hi, I'm Anushka, a year 3 student in computer engineering. So the reason I chose this course is because ever since I got my hands on electronics, I realized that I spend my majority time on social media applications or maybe even doing research for school projects. So this made me want to explore more, and the future in technology is also very bright and gives me an opportunity to be more creative and innovative.
Right, thank you. So what have you learned in the project so far? How is it different from doing actual projects and the one you actually learned in class?
So currently I'm doing a AI-based project. So it makes use of AI and industrial cameras such as Bosch to be used in daily classroom tasks such as attendance taking or also in an examination situation. So there is the use of facial detection to see the direction in which a student's face moves in to see if there's any abnormal behavior such as cheating, or also in daily classroom tasks such as attendance taking, where facial recognition will be used and teachers will be easily able to see at the end of the class who was absent and who was present.
As a student in the classroom, does it sound a bit scary? But not to worry. This is just project POCs. It doesn't mean that every classroom in Singapore Poly is being implemented. It's proof of concept. It's potentially showing what people can see. So my next question to Anu is, what are the challenges you faced and how you overcome it?
So far, in the past few weeks of internship, the challenges I've faced is the steep learning curve, because when I first started the project, I had to learn a new programming language, Python, and also to extract metadata from industrial cameras to make it more efficient. But with the help of my peers and supervisors and a lot of self-directed learning, I was able to learn more efficiently and make improvements to my project.
Wow. Okay, so what do you think about the technology you learned? How will it impact the industry?
I think the industry is getting more and more digitalized. So this kind of AI cameras may be deployed in many kind of industries, not just classrooms, especially in such times where, like during the pandemic, a lot less human contact and effort is required.
I see. So what is your plan after graduation in the future?
After graduation, I hope to pursue the networking side, because the past few weeks working at the 5G and AIoT Center, I realized that networking is a really important part of any AIoT system. So I would like to pursue this path to be able to balance my programming and networking knowledge.
All right, so I wish you good luck since you are having your final semester with us. I would like to share a piece of news with everybody. Next week, we will be having this iTab show in Expo. It's a range of dates from 22nd to 24th. Right, so SP will have a booth there, and we're going to showcase 5G in advanced manufacturing. So if you're interested, please join us, and we'll be more than happy to show the projects that we have in the exhibition. Thank you. So the next section, I'm going to see, probably I'm going to bring Adrian back, and of course together with our facilitator, Ken. So please key in the questions.
There's this COVID situation going on. So what we're trying to do is to minimize human contact to prevent the virus from spreading. So we came up with this contactless method by using a video analytics-based camera with built-in artificial intelligence to manage these facilities. We are trying to simulate a museum environment. So the customers will purchase the tickets and submit their picture for on-site verification. So when they arrive at the museum, there will be a video analytics-based camera deployed at the entrance to verify its identity. There will be many cameras deployed in the museum to monitor areas of interest, such as restricted areas or manless information counters. So when the customers need help, they can approach the manless information counter and wave their hand to notify the staff. So the staff will receive notification alert, then they can approach the customers for assistance. When the customers enters a restricted area, the camera can detect and alert the security guard. It can also analyze the visitor's movement, so they can track visitor pattern. For example, how many visitors are coming in and out of the museum. In order for the collected data to be displayed on a dashboard, I needed to write a piece of software to extract the metadata. So this part needed a lot of in-depth knowledge of networking and protocol, which took me a lot of time to master. So through this project, I've understood how the whole system of video analytics works. I see that there is a trend for video analytics to become a generic sensor. In the future, I hope to see more of these technologies used in other areas and facilities.
Is it okay your handphone? Is it okay to put it at the front? Maybe it's interfering.
Okay. 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 Testing 1, 2, 3. Yeah. Good afternoon. Welcome back again, everyone. We are pleased to have you back during our question and answer session, where we have our both experts here in the room to answer. Let's go through some of the questions and answers that you have put in our live chat. So for a start, one of the questions that we have been asked is, what resolutions do the HDRX cameras come in?
Right.
Adrian.
I would expect that this is for me. So essentially, HDRX camera is still very new to the portfolio of cameras here at Bosch. So today we have basically one series of cameras, which is the FlexiDome 8000. And it does come in 3 different types of resolutions. So standard, you have 1080p. The second one you do have is a 6 megapixel camera. And the last one is, we actually do have this also in 4K. Right, so you can imagine the improvements in picture quality based on those HDRX capabilities, even more so with the higher resolution cameras.
All right, thanks, Adrian. We have also another interesting question here. What about AIoT in MRT?
So,
it's over to you again, Adrian.
I think the question is not super clear, so I'll try and hazard a guess as to what it is. So the question is, can AIoT solutions be implemented in MRT? I think the answer is a clear yes. I think even more so based on what we've kind of mentioned earlier, both from my side as well as Chi-Seng from Singapore Polytechnic. AIoT solutions benefits a lot because of this advancement in interconnectivity between the sensors as well as enabled by 5G, right? So essentially, you can have super low latency readings from the various sensors, and it's transmitted via 5G, and you don't have the typical latency problems that you have. So in short, would AIoT solutions fit into an MRT environment? Sure. In fact, we have gotten requests from not only the MRT here in Singapore, but also in different parts of the world, to start looking at AIoT solutions, both for managing things on the train, as well as managing situations on the train platforms and stations. So maybe Chi-Seng can add a little bit more from the 5G side.
Right. Of course, AIoT in MRT, and as you mentioned, MRT means is moving. So if it is moving, it means the solution we deploy has to be wireless, right? So if it is wireless, and it need to be very fast and very quick with very low latency. So that, of course, brings in the need of 5G. Of course, everybody will argue 4G can already do the job, but remember, as AIoT get widely deployed across various locations, some in the MRT, like you mentioned, like the question is asking, some are in the campus, that infrastructure support for the entire city is very much needed. So 5G is definitely the next step to boost AIoT application across every industries.
Mm-hmm.
And just to add, right, Chi-Seng, 5G is 100 times almost 100 times faster than 4G, right?
Yes, on theory, yes, it is.
Okay.
Everything on theory, yes, it is. But on practical, that's why we have this live test bedding here in Singapore Poly.
Yeah.
So you feel free to come and approach us. We are more than happy to collaborate, and you shall see the speed improvement. But on paper, yes, Ken is right. It's about 100 times.
Fantastic. Yeah. So many use cases can be conducted in this center here.
That's right.
All right. Let's move on to the next question. So besides video-based AIoT use cases, what are the other AIoT collaboration Singapore Poly and Bosch do together?
Okay. So yeah, this question is very obvious. Is to Singapore Poly, right? Actually, yeah, we are very happy that Bosch actually collaborate with us, not just the video-based AI. We also have actually been using the multi-sensor, this sensor called Bosch SDK. We have that lab, the lab that you see just now in the earlier video where we run the AIoT video-based exercise, also has IoT equipment. So we have that 8-in-1 sensors being interfaced to a third-party IoT gateway, and that data was being aggregated and forwarded to another cloud provider platforms. That gives our student a complete end-to-end AIoT system, from sensors to gateway to cloud platforms and application creation, like the intelligent insight that you see earlier on. Of course, intelligent insight is one of the choice, and the lab actually offers many more learning opportunities. That is another aspect. So not just video-based AI, but also the IoT part. Not forgetting, of course, together with Bosch Restaurant, we have an advanced manufacturing lab that shows and teach students how to use IoT in the I 4.0 industry part.
Okay. Thanks, Xu-Sing, because AIoT also does what we call predictive, kind of element in there.
That's
rather
right.
than a reactive, right?
Yes.
Therefore, AIoT is always the leader.
That is correct.
Yeah. All right, very good. Thanks for the answer, Xu-Sing. Now, we come to the next question. What about the security in AIoT? I look at you, Aiden.
Security in AIoT. This is a rather big topic. So I try to answer it in small chunks. So when you look at security from an AIoT perspective, it's really not that different from security in a typical IT system, right? Because at the end of the day, what you have is you have on the one end edge devices. So in this case, it might be a camera, it might be a sensor of sorts. You then have the transmission infrastructure. Yeah, so in this case, for example, 5G and you know, in the olden days, there might also be 4G or even Wi-Fi and what have you nots. And then you have the central piece, right, where all the data flows back in and where you process all this information. So when you really want to discuss security in AIoT, I believe we need to kind of look at the entire thing holistically in these three separate aspects. Right? So at least from a Bosch perspective, we are always very, very particular when it comes to ensuring cybersecurity elements are implemented into our devices, where possible, of course. So for example, in the Bosch camera, it is, when you look at it, it's essentially, if you think about it, it's a computer with lens, right? So by taking that approach of looking that as an actual intelligent device, we have not neglected to build in the various different cybersecurity capabilities. So it's a very long list, but I'll quote you two examples. So the first example is the fact that within the Bosch cameras, what you can do is you can embed certificates that's into the device itself. So what these certificates do is they function like identity cards, like IC, right? So like identity cards, such that the device that's being connected to your overall system can be verified, right? So that's one way. The other way that we kind of make sure that cybersecurity is a big part of the AIoT story is the fact that within our device, we do have a dedicated hardware chip inside our camera that is called TPM, right? So this trusted platform module, or TPM, is an actual hardware piece where all the important cybersecurity elements like your cryptographic keys. That's where it is being stored. So this is important, right? Because when your device gets physically taken and taken apart and hardware hacked, you want to be able to have some kind of fail-safe. So this is what the TPM does in that sense. So in short, when you kind of put it all together, I think the big misunderstanding is AIoT, a lot of people are focused on the system side, so how do I secure my cloud platform? How do I secure my software and so forth? But I think it's also equally important, if not more so, that you place importance in cybersecurity from the edge itself. Because as what Chi-Seng mentioned with 5G, today with the interconnects provided by 5G, you can essentially take the camera and plant it anywhere, right? So how do you know that camera really belongs in your system and make sure your system's not compromised, right? So have to think in that direction, in my view.
Okay. Thanks, Adrian. And I think Adrian is right to the point, because a lot of our cameras are actually located or deployed in very important high security infrastructures, right, Adrian? Maybe some examples you can give.
Well, plenty of them. Yeah. So if you head out to, like now that travel is reopening again, right? So if you get the chance to head off to the airport in Singapore, you would see our cameras being implemented. Hopefully, now that tourist sites are reopening up again, if you make your way down to Gardens by the Bay, you would see our cameras there as well, right? So there are a lot of examples, even securing some of the upcoming MRT line, Thomson line. Yes. So that's also going to be a Bosch solution with our cameras around. So yeah, it's super important, at least from our perspective, because maybe I didn't iterate this earlier, but if your system is compromised from an IoT angle, it actually is a bigger risk, right? Because at the end of the day, systems usually are interconnected. And even if systems are not interconnected, your credentials are usually interconnected. Chances are that you would have maybe the same password or the same username being used across different systems. So if the AIoT system is an easy breach point, it's actually a much bigger problem. So that's also something that I urge our audience to kind of consider.
Actually, security is a very big problem. We should see it in terms of total security. Any part that has a potential to be hacked, it must be protected. So I think Adrian has been putting a lot of words and explanation, trying to explain to everyone. It is a total security that you must look at, right from device to gateway to cloud to the application you create, and at every point when they get connected to each other, at every part that can be tapped, data in transit must be encrypted and protected. Yep. And the data locally must be encrypted. So this kind of AIoT good practice has to be built in mind for all the future engineers that's working on AIoT. So they must have that security mindset in mind when they design a system.
Perfect.
Thanks, Chi-Seng. I think it's a very good point there. The security is paramount actually in today's world, right? Let's move on a little bit to the more technical details. This is, of course, to Adrian. Will HDRX reduce FPS, frames per second?
Oh, actually, no. So you have to think about it this way. Frames per second is actually an output post-encoding, right? So the camera image comes in, there's some encoding that happens so that it becomes digital packets, right? So the frames per second is post-encoding. The HDRX piece happens pre-encoding. So there is a relation, but it's not a direct relation to the sense that HDRX reduces that frame per second.
Okay. Hope that answered your question regards to frames per second. All right, now we can move along. There's one interesting question here about 5G. I look at the thing here. So can 5G be applied to autonomous driving of electric vehicles? For example, object detection, road signs, traffic lights, and so on and so forth. Yeah. Today we have probably more Teslas on the road. Yeah.
today?
Right. I would say a lot of times the technology is there. POC definitely is suitable. But a lot of times you can see that the technology wasn't being deployed that quickly. It's all mostly slows down because of policy that certain government has to take into consideration, especially when safety of human comes in. So people may be asking, hey, why can't we let a 5G controlled car and all that kind of stuff? But it all goes back to when there's safety issue to human, do we allow that? So different government has different stand at it. So as Singapore today, we understand it is not there yet, but it doesn't mean that we will not be there. So I would say that in terms of technology, definitely it's possible. But whether we are really going to get it, all the other human aspect has to be taken full consideration, because all this will actually eventually go onto the road and we are the one that's going to use it. But for road signs, no issue. Road signs, all these are things that you even need 5G because it's going to be in massive numbers. So can our 4G sustain and be able to control as the entire island now starts to get connected? I think 5G is the answer.
Yeah, and an extension to the question, it was also asking, can AIoT replace the LiDAR technology for autonomous vehicles?
All right, so it all goes back to how responsive you want your applications to be. So if it is real time, time critical, and is very to be very strict, again, human safety is involved. It is always good to have at the edge. When we say at the edge, is all the processing is done in the computer that is allocated at the site itself. So I would say that LiDAR at this point of time, I don't see it going away because its responsiveness is going to be faster. It's going to give you that faster response as compared to linking a sensor to 5G. You nothing beats that edge deployment. So if it depends on your needs. If you really need that very short response, then you will still need the LiDAR to be around. And in fact, it can be a hybrid or complement. So the LiDAR can be the sensor that gets connected to 5G and sends data to the cloud. Right. So yeah, that's my I hope I answered the question.
Yeah, so I know autonomous vehicles today are probably one of the hottest topic, right? Can we sit in a vehicle and have our Starbucks at the same time, right? Without causing any instances, right? So what do you think of that? Will that be of the future?
Right. For the future, I think everybody aspire it to happen. Again, I know I've been very naggy about this. There's security things again. I think you have watched a lot of videos. Technology, proof of concept. This is definitely possible. Are we going to expect this soon? I would say maybe in the future, but not now at this point, because of a lot of consideration to be taken care of. Yeah.
Okay. Anything to add?
Regarding autonomous vehicles?
From the view, yeah.
I think Ji Sing is kind of right. At the end of the day, the technology is there, but how do you utilize the technology to fit the real living world is a very real topic, right? So it's not only policies, but also, do we know enough about the tech and how it's being used so that, you don't have too many unforeseen outcomes, right? So at the end of the day, I think regardless, better interconnectivity, I believe, is a key part to this puzzle. So 5G is what we have as cutting edge today. Moving forward, you might have 6, you might have 7G, right? But the fact that, because the big idea really is about different sensing units, giving you a complete picture about your environment. So even though you might not have 5G controlled cars, but cars may still be able to gather information and send information via 5G, so that the car that's driving on the road, if it's autonomous, it might be informed of accident that has happened in front via the 5G network and make, the on-the-fly adjustments as needed. So it could be applications like that, not necessarily just about controlling cars via 5G, in my thought.
Yeah, you talk about big data, we talk about edge computing. I think these are very important elements to make 5G and AIoT work together. One of the other questions also somebody has asked, are there any limitations to AIoT today based on what we have?
Sure. Don't know if Jiseng wants to take a stab at it, but I can go first.
Yeah.
So,
Right. So limitation of the AIoT, of course, will start off with what is the maximum capability of that particular technology. So 5G says that it is about 100 times faster than 4G. It says that it is a sub-milliseconds delay. So anything, if you think that you need better than that, obviously this technology is not suitable. So that is the limit. But overall, to everybody, AIoT sounds maybe very simple, just 4 letters, but actually it is a very complicated system and very difficult to set up. Just imagine you have the device at the edge, you have the gateway in the middle, you have your network infrastructure to send data, you have the cloud provider to host your server. Eventually, your application, you need your applications to be running. Remember, any one of them is not working, the whole thing is not working. To the end user, the whole thing is not working. So I would say that the key limitation we have today is to have that knowledge and that capacity to fully sustain and make it operational at all times. I think that is the major constraint that we have at this point. I do not know. Yeah, maybe let's Adrian comment on some other parts aspect.
okay. Let's see what I can add to that. I think limitations. First limitation for AIoT, I would think, is basically from the sensing side, right? So you can always build things that are more and more sensitive. Doesn't matter if it's a camera, doesn't matter if it's air quality sensor or what have you not, right? But at the forefront of technology, there's always going to be the limit of how much sensing is possible at one point in time. It will improve, but that will always be a moving limitation, if you will. Second of all, I would also think from an AI perspective, the holy grail today is you want a general purpose AI, right? So you want an AI that's able to adapt to situations and take action regardless of what input that comes in. So multi types of input, multi types of output. The AI then becomes the one that judges how best to do it. So that's the holy grail because it doesn't exist yet. Yeah. So today, what you see, especially with AI, it's usually very purpose built, and it's purpose built based on data that's already collected for that purpose, right? So those will be the other limiting factor as I see it. So in other words, if we think today a lot of things will be can be done by AI, it will eventually get there, I think, but we will still be some time away because of the nature of how specific the AI is. So that's my take.
Thanks, Adrian. Of course, there's always the semiconductor shortage. That itself is already a limitation to what we have today. All right, let's move on. I think there's one last question here. Again, related to vehicles. Can 5G AIoT be possibly implemented on vehicle-to-vehicle networks?
All right.
Yeah, that's a question.
So for 5G, there's this aspect they call CV2X. So this is specifically designed for vehicle-to-vehicle communication. So activities like this will definitely be very interesting to look at. Of course, the direct competitor of CV2X is we know. I don't know whether you all know. It's actually DSRC. So today for vehicle-to-vehicle communication, we look at DSRC. But for 5G in vehicle, look forward and let's see what CV2X can offer us. Yeah.
Thank you. And where there are sensors on the roads and lampposts to monitor the speed of cars, traffic density, cars can communicate with one another by 5G. Is it also possible?
Yes, it is possible.
It's possible,
It's
right?
possible. Yes.
Okay.
With CV2X, it is possible.
Okay. Then today, when we have all our GPS and our Google Maps and all that, right? How does this actually function? Is it a 5G AIoT kind of technology behind,
And-
telling you how to get to your route at the fastest time.
Right, so all these data are actually fundamentally IoT at this stage. So they actually sense data to, of course, the Google server or whatever server that they have. Because it has to be in the cloud that oversees a wide span of area. So the edge devices will be responsible to send over all their respective location information, and then it is really running another applications that do the planning. All right. So these are the concepts. It will just make all this system updating in real time. So it means that potentially this server-based system can now help to do real-time route planning rather than pre-plan for you before you set off. Right now, if there is any traffic jam, yes, they reroute for you, but probably things gets a bit too slow. You can't get that immediate reaction. So with 5G coming in, you will find the user experience better when you are using this kind of application.
Very good. Another question. What are the main challenges when let's see this. What will be the role of the driver if the vehicle becomes autonomous? Well, the driver can have time to watch his Netflix, right? That's just a quick thought I have.
Isn't the driver the passenger supposed to go to the other side?
Maybe that could be one. What are the main challenges when implementing AIoT into our daily life, and how do we benefit from our AIoT?
All right. In fact, you are already enjoying it. Maybe make it very simple, straightforward to you. In the early days, we used to my generation. Maybe it's the same generation. I don't know about your age. We used to rush home on time to catch your favorite show.
Yes.
But today, I believe nobody is doing that anymore. You are expecting it to come to you on the dot. When I need it, I want to watch it. And when I watch it, I want to have full control of it. Pause it, go toilet, come back and continue. So see, this is really changing the world that we are living in. This is one very good example of actually how technology influences us. And the other aspect when it comes to connectivity, of course, 5G and AIoT Center, we focus a lot on connectivity. The other technology that you have been using every day is actually our wonderful Wi-Fi. I mean, if you go to any places, shopping mall, your friend's home, I believe the very first thing you ask for is what is your SSID and password. In that sense, you want to stay connected. So this is also a part of the AIoT influencer. So I will say that the experience that we have is going to get better and better when our technology gets faster and faster. Because today the internet is no longer just on social media, where you surf a web, watch video. If you realize now it's a lot more, and it gets when all the convenience that we are enjoying in our daily life goes into corporate and enterprise.
Mm-hmm.
All right. Thank you, Shising. I think we all know that we want better lives. Definitely, we want to also come to the end of the question and answer. We also have the QR code. If you have anything, other further questions you want to engage us on, it will be on the screen in a short while's time. Once again, we want to thank all of you, our customers, our partners, staff and students of Singapore Poly, and everyone who is out there watching this Tech Talk. Thank you once again. Have a good day and see you next time. Bye-bye.